So let's jump into the examples and see if we can apply some of this new knowledge that we have, starting with example 1. Find the measures of angles 1, 2, 3, and 4 listed, given that lines M and N are parallel. So we got some transversal L, we'll call it, and therefore, what do you know about some of these angles? Because I didn't give you any of them. I just labeled them. The only things I did give you were the fact that angle 2 is that length and angle 3 is that size. And so what do we know about angles 2 and 3? What type are they? Well, they're on the same side of our transversal, and they are both interior, inside of the parallel. And if you remember, these are definitely not the same. This is acute, this is obtuse, too big. So what did we know about the same side interior angles? That the measurement of angle 2 plus the measurement of angle 3 had to be equal to what? Hopefully you said 180. And because I know that this and this are 9x plus 9 for angle 2 and 7x minus 5 for angle 3, I can substitute those out there and then solve for x. And so doing that, I'm going to go ahead and combine my like terms first. So I'll take all the x's first, which there's a positive 9 and positive 7 of them. So I have positive 16 x's. And then a positive 9 with the negative 5 gives me positive 4. And all that is equal to 180. So next step, I will go ahead and subtract 4 over. And now I got 176. And then I'll do my long division as I taught you guys in the previous, hopefully you watched that one, previous video. When I divide by 16, check out how I do long division without the long part. I know 16 goes into 17 how many times? Obviously just once. But I'd have 1 left over. When I bring down that 6 that I haven't touched yet, now I can divide the 16 into that, and I know it goes in 1 time as well. And now that I know that my x is 11, I can plug that in here, in there, and figure out what both angle 2 and angle 3 are, which means I'm halfway there. So plugging in 11, I get 9 times 11 plus 9 more. So that's 99 plus 9, which is 108 degrees, which makes sense for my answer because I know that this is an obtuse angle. Wait a minute. I actually know angle 1 then as well, don't I? Because those are what kind of angles? Hopefully you said vertical. And therefore I now know angle 1 is also 108. Wait a minute. I also know that angle 4 is the same as angle 2. Because those are what are called corresponding. So this line right here, if I just took line M and I slid it down this, it would lie exactly on this one. And so since these two lines create angle 2, if I move this one down, it would also create this angle 4 the exact same way. So therefore, I also know angle 4 is equal to 108 degrees as well. So the only one that I really have to also do work to get is whatever 7 times 11 minus 5 is for my angle 3. So I get 77 minus 5, which is 72 degrees. Now I also could have gotten that because I know that these have to be supplementary. So 108 plus what would get me to 180? 72. So we know for a fact that we did this correctly. Okay, so that's why we learned all those different types. This is a good example that kind of shows you all the differences of the types that we've been dealing with together. So let's check out these triangles, which look pretty similar, I would say. There's that word again. Now notice I did take and flipped one over, so you really got to pay attention to how they tell you, which I told you in the words that they are similar. And therefore you should know that D and G, those two correspond to one another. E and H second in line correspond, as well as the last ones, F and I. So if they want us to find all the unknown measurements of these, I already know that D and G correspond to one another. So since I know this is 53, then that has to be 53. Since I know H and E go together, and I know H is 98, then so is this. And lastly, F and I. Oh, shoot. They didn't tell us about either of those, right? So we're stuck. We can't find those. Well, remember, we also discussed what the sum total of a triangle is, and that was 180. So if I added 98 and 53 together, that gives me my 11. That's 10 and 5. So I'd have to add 150 plus 30 would get me to 180, but I have 151, so I would need 29 more to make my 180. So that means that this would have to be 29 and this would have to be 29. And now we found all the unknown angles that was not provided in blue. Because I know that they are similar, I know that corresponding angles have to be congruent, the same. Let's keep moving along and deal with another similar triangle. This time they're calling it MNP and QSR. And if these two are similar, then we know about their angles. Corresponding angles are congruent. But what did we say about the sides? Because this time, that's what they want us to know, are the unknown sides of triangle QSR. So they gave us one. We need to therefore find what QS is as well as SR. What are those measurements? Well, remember, in similar triangles, we know that their angles are the same, corresponding angles, but corresponding sides are a certain ratio. We call it a proportionate. Okay? They are proportionate to one another. So the cool thing is you can kind of take this however you want. If you wanted to do 8 over 12, that's fine. Then you'd have to do 10 over this QS. So I'm going to go ahead and label this as X and this one as Y, just so that we can label it a little bit better. And therefore, if you wanted to do the, like I said, 8 over 12, then you can do 10 over X, or you can do 8 over 10 as long as you do 12 over X. You just have to be consistent no matter what you do with these to set up your fraction equals another fraction. We call it proportion. So in this case, I'm going to go ahead and keep it simple. I'm going to do 8 over 10 and set that equal to 12 over X to start. And this ratio right here is really nice because not only can I find it, I can actually reduce and simplify if I wanted to. Now, one thing I want to make sure that you guys do not do, it happens all the time, is do not cancel the 12 and the 10, okay? Don't cancel across an equal sign ever. The equal sign separates the two equivalent sides, all right? So the one thing, if you wanted to do that you could, is the 8 over the 10, okay? So if you wanted to divide this by 2 and get 4 and this by 2 to get 5, that's fine. Now you have two options at this point, actually a few more, but I won't go into too much. You can either multiply across the equal sign at a diagonal. We call it the cross product, okay, because we're multiplying product across the equal sign as well as the numerator and the denominator. Or you can go ahead and multiply by the LCD, which the least common denominator of each of these would be 5x. So there's a couple different ways to do this. Most people will just not think and do it this way and say 4 times x is 4x. And then 5 times 12 is 60. And so your last step there would obviously be to divide, to undo the multiplying, to get that to be a 1x. And then 4 goes into that. If you wanted to, you could divide by 2 twice. But 4 goes into 6 once with 2 left over. Bring down the 0 and then 5. So we just found that length QS, which we called X to make it simple, is a length of 15. Doing something similar for SR, which we called Y. we can go ahead and set up that 8 over 10, which since I went here over here, I don't want this. I already found it. So instead of 8 over 10, I'm going to have to do 8 over what? And you can actually do 10 over, but I would use the things that you were given rather than the one that you just found here. So I would do 8 over 12 and set that equal to 12 over y. And again, go ahead and cancel. 8 and 12 each have a divisor of 4. So 4 goes in this twice, 4 goes in that 3 times, and then you can do your cross product. 2y equals 36. And then go ahead and take half of that so that you get what y or rs is, or sr, and that would be the length of 18. So two different ways to use similar triangles, both on the inside, the angles that correspond to one another have to be the same, and then the outsides, the side lengths that correspond to one another have to be proportionate. So here's the last type that I'm going to go over with you all, and of course, another word problem to end with. That is typical for this text, so get used to it, all right? So it says a tower casts a shadow 180 feet long. At the same time, the shadow of a 9-foot tall truck is 15 feet. Find the height of the tower. So this is something that can actually happen in everyday life, right? You can actually use shadow lengths and things like that to find a very tall building without sitting and having to rappel down the side of it and measuring it. So first thing I like to do with word problems is, like I just did, read the whole thing, figure out what I'm given and then what I'm trying to find. And then thirdly, with something like this, I want a visual. I want to see what I'm dealing with here. So it says a tower. Now, you don't have to get too fancy. Here's my son, okay? I won't show my daughter, but here's my son, and then here's the tower, right? Don't worry about drawing it too fancy, okay? The one thing I do know about this is it's going to have some shadow that's going to cast. Now here's the problem. As I said that, I drew that. And if you were ever to look at your shadow when you're standing up outside during the day, where would you look to see your shadow, Peter Pan? Yes, you would look down on the ground, okay? This would be your eyesight that you're looking at here, okay? This is not the length of the shadow. And remember what the name of this class is called. Trigonometry, the geometry of triangles that we're studying. So guess what? Almost every single time that you're going to be drawing in this class, a triangle. In some form or fashion, you're going to have to end up with a triangle. So when I'm drawing this, I'm going to be drawing that. And notice we're not drawing any old triangle. We are dealing with a right triangle. Okay? And we also at the same time had our truck, right? Which is also going to have a shadow. Now here's the problem. When you draw it like that, it's so small you can't even see it. Okay? It starts getting so small that it's difficult to even work with. So when you're drawing these, just over exaggerate and know that you're going to have that truck be a size that you can deal with, so that when you draw the shadow length, you're dealing with a large enough thing that you can actually work with, okay? So now I'm going to start labeling these two drawings. I'm going to go back and read. It says a tower casts a shadow of 180 feet long. Okay, stop there. Where should I be drawing 180 feet? Good. Hopefully you said down at the bottom. Remember, our shadow is going to be from here to there, wherever it ends, depending on the time of day. Okay? Then, keyword, at the same time, because that means the sun has not moved yet. We're going to have similar triangles here, even though my drawing doesn't look very good. The shadow of a 9-foot tall truck is 15 feet. Now, that's kind of tricky the way that they worded that, so be very careful and pay attention. A tower casts a shadow of 180 feet. We got that. At the same time, the shadow of a 9-foot tall truck is 15 feet. So how tall is the truck? Well, that's the 9 feet. And the 15 feet is the shadow of it. which would be down here. Now again, the cool thing about math is it doesn't have to be drawn to scale, because I know if this is 9 feet and this is 15, this should definitely be the longer piece. Well, if this is similar to that, because it's happening at the same time of day, then I know that this should be longer than that when I work it out. So the easy part is now hopefully in sight, and you can see that this is what we're trying to find, the height of this tower. So I'm going to put x over 180 is equal to, again, just make sure that you're consistent. If I'm doing this over that, then I have to do this over that. So 9 over 15. And again, now you just solve for x. So the first thing I'm going to do here is divide this by 3. And then I will do my cross product. 5x and then 3 times 180, which I know 3 times 100 is 300. And 3 times 8d is 24 or 240. So a total of 540. So my last step then would be to take this and divide by 5 to solve for x, which is what I called the height of my tower. Again, just be careful when dividing. 5 goes into 5 one time. 5 does not go into 40, so I have to put a placeholder of 0 there. 4. And then it does go into 40 8 times, which holds true with what we said it had to be less. Just make sure that you put the measurement at the end of it. All right. Short and sweet on this second video here. I hope you guys are doing all right in this first week. Hang in there. Keep plugging away. Remember, these first couple of chapters are going to be very important to your success in the long run.